Hi, welcome to today's webinar. We'll get started in just a couple seconds. Okay, welcome to today's webinar called Semi-Automatic Hex Meshing of Complex Parts with Coreform Qubit. So I am Matt Cederberg. I'm the CEO of Coreform, and Greg Vernon, the Coreform Director of Engineering, will be presenting the webinar today. And this will be about 30 minutes. And the focus of the webinar is to explain to you one of the most powerful features of Coreform Qubit that can be used to create nice hex meshes, which is the composite surface tool. And just a little bit about Coreform Qubit, if you're unfamiliar with it. Coreform Qubit is a tool used across industries for advanced meshing for challenging simulations. So it's used often either if you have a fully integrated preprocessor and solver but need advanced, especially hex meshing capabilities. It's also used if you're using a solver that doesn't have a preprocessor, and it can give you all of the CAD import and cleanup and hex meshing that you need. Also at Coreform, we're developing a new solver based on isogeometric analysis, and we've added capabilities to that to Coreform Qubit as well. But today, I guess before we get started, I just want to have a little poll so that Greg can frame his remarks to understand who's in the audience today. So we're just curious what your experience is with Coreform Qubit. If you could respond, how many models have you successfully hex meshed with Coreform Qubit? Have you never made any models yet? Have you done just a few, maybe 1 to 10? 10 to 100, and then we figure once you've done about 100 models, you're an expert. And so we're curious if we've got any of those in the line as well. So let's leave this on for another couple seconds. Okay, so here's the results of the poll. So Greg, it looks like the majority are just beginning. They're just starting out with Coreform Qubit, which is probably perfect for the material that you've got prepared today. In case you find yourselves a little bit left behind, what Greg's going to assume is that you have basic familiarity with Coreform Qubit. If you don't have that yet, you can go to our website, go to the tutorials drop down under Coreform Qubit, and then if you scroll down a little bit, you'll see these step-by-step tutorials. This Getting Started tutorial PDF gives you the foundation of everything that you'd need to follow along today if you want to see the recording that we'll post later on YouTube. And then for more detail later on, you can come down to these Qubit 100 and Qubit 200 tutorial courses that will really build on what Greg's done today. And finally, just a word about hex meshing in general. So our opinion about the emotions surrounding hex meshing, it is often, I mean, sometimes it's kind of fun, but it's often a necessary evil of just what you need to do to get a well-behaved, efficient simulation in most traditional solvers. And so at Coreform, we've created a Qubit, which we believe is the industry's best hex meshing tool. Sometimes it's still honestly not the funnest thing in the world. And so what we've done is made available a lot of our expert engineers that can help you and give you guidance throughout the way. So you can always go to our forum. That's forum.coreform.com. We respond pretty quickly. And especially if you're getting a free trial, we really want you to get onboarded fast. Your time is really valuable, and we've realized that if we spend just a session or two with you meeting and discussing your problems, we can either recommend Qubit or help you get on and evaluate something else pretty quickly. So after the webinar, if that looks interesting, please feel free to reach out to me and we can get something scheduled with you one-on-one. With that, let me turn the time over to Greg. And I guess final word, throughout the webinar, if you have questions, please just type them in and we'll respond to them as soon as we can.
All right, well, thanks, Matt. So as Matt said, let me just double check, Matt, that we're seeing my Coreform Qubit screen.
Yep.
Great. So yeah, as Matt said, I'm going to talk today about a composite surface tool, which you may be familiar. It creates virtual topology. And it's a really powerful tool for being able to create hex meshes on some difficult to hex mesh parts. But it's oftentimes a bit of maybe a confusing tool, or maybe not sure where to use it. So hopefully today we'll be able to answer some of those questions that come up. So what I'm going to do is I'm going to import a couple of geometries and show just applying composite surfacing on those two. So I'm going to import a simple assembly that you might normally in a large assembly, you might build a mid surface and model these as shells. But what we're going to assume here is that we've got maybe some failure, that some nonlinear deformation, plasticity has been going on in this assembly, and so we want to perform a nonlinear high accuracy analysis, and so we want to go with hex meshes on this kind of subassembly. So I've got three models here, or three parts. I've got a bolt, and then I've got these two hinges. Now, in Qubit, the workhorse in Qubit is a sweeping tool, where you would take a volume and you would select source surfaces and then target surfaces. And it's not a problem that there's maybe, you can kind of see that we might want to sweep through the thickness of this sheet metal part. It's not a problem that there's multiple source surfaces that we would want to maybe start our sweep from, but it is a problem that we'd have multiple target surfaces. Qubit only supports 1-to-1 or many surfaces to one surface sweeps. And so this would not be a sweepable topology. But with compositing, what we can do is we can take all of these surfaces and essentially make them one macro surface and do the same with the other surfaces, so that we would then have a 1-to-1 sweep. So I'll show that here, building that. So if we just draw this volume by itself, I'm going to color my curves black here so we can see as this happens. Now we're going to access this is through the command panel. I'm using the classic navigation for the command panel, which can be set in the tools options under the command panel's classic. You may not have the classic mode. I just grew up with the classic mode, so that's what I'm familiar with. So your ordering might be a little bit different. But where you're going to find it is under Surfaces, Modify, and then Composite. And we call it virtual geometry, which is kind of our synonym for virtual topology. They mean the same thing. Some of our operations in Qubit are virtual, and you'll see that in a little box here that'll kind of identify that as such. So I'm going to select my surfaces. Now I could try to manually go through and select multiple surfaces, but that might be a lot of clicking. So one of the things that's really cool in Qubit is if we select a surface and then right click, we have options for selecting multiple surfaces at once. This is like a cavity, so we could select your entire cavity, and that selects multiple surfaces. But it's also, these surfaces are all tangent and continuous with each other, so we could also have selected continuous here. So I'm going to select those. It automatically populates the pick widget here for how many surfaces I'm selecting. I'm going to go ahead and apply. And what you'll see is that once I've hit apply, what had been solid black curves are now these dashed lines. Those dashed lines essentially mean that the meshing tool is going to ignore those boundaries. So just to show that real quick, if I build a quick mesh on this, you'll notice how these elements, if I flip back and forth, they still are matching to the geometry, but they're no longer restricted to the topology of these surfaces. And if I were to refine the mesh more, we would get closer and closer geometric approximation. But now I'm going to go ahead and select the other surfaces on this other side. I'm going to composite those as well. I'm going to delete my mesh real quick. And so I can now mesh this volume. So if I go into my mesh mode, volume, sweep, I can then pick my source surface. Notice it's a single ID now, and then a target surface to a single ID. and that builds the mesh on that part. Similarly, I can do that with this other part. I can take that same approach of doing composite surfaces. The one challenge here is it's not actually sweepable because I've got some linking curves that essentially take a finite distance to a zero length. So I can't sweep along that. But I can again use compositing to say, well, I can kind of see what's going on here. I just need to have linking curves that go from one surface to the other without kind of disappearing. So I'm just going to select these surfaces and composite them together into a single macro surface. And so now we can see that that topology is going to be ignored by the mesher. And I've got a similar case over here. And so now with that done, I can select my volume, select my source surface and my target surface, and build my mesh. Now I could even have gone a little bit more heavy on my compositing. We see here that there's maybe like a small surface here as well. I could have composited that in too. So anyways, Qubit's thinking here real hard. I've got a development build here, so it's got a little bit of maybe some stability issues. So we'll wait on that, but that'll finish meshing at some point. I'm also going to show on another assembly or another model that's maybe a little bit more challenging. So let's say that we've got this gearbox housing and we want to run an analysis on this, but let's say for sake of argument that we noticed that we'd had maybe some failure occurring in this standoff here. And so we want to have maybe a detailed mesh of the fillets on this model or on this subregion, but we don't really care about the fillets everywhere else. As you can also see that there's also some kind of orphan curves and maybe some embossed features that we wouldn't want. So I'm going to show some cleanup first of this model before we go with meshing. And there's like a free surface here too. So one of the things I like to do is we can clean up all of these free curves either by selecting them in our model tree and deleting them. We could also run a command that's say delete curve all in our command line, and that would delete them all. Or through the GUI, through the curve tool delete, and we just say all, this will only delete orphan or free curves. So it won't delete curves that are already part of a volume. So you can see I deleted that and some of these curves have gone away. I still got this surface here. I can delete that as well by just deleting all. So it's just deleting those kind of unowned surfaces. Now, compositing is a virtual operation with surfaces, but we also have real operations like the, so if we were still under the geometry mode, surface, modify, if instead of compositing, we chose remove, we'll see we don't have that virtual geometry box here. So this is going to be a real geometry operation. And what I can do is I can say just select a single surface inside of these subregions. And notice if I have remove cavity on, that will then remove all of these surfaces, which would almost have been the same as if I'd right-clicked and said select cavity. So you can kind of see what's going to happen if I had that remove cavity on. I could only select a single surface and remove them from the model. So just some like really quick tools to do some of that. Additionally, we mentioned previously that maybe we don't want to have to worry about a lot of these fillets. So we can select surfaces quickly. We can select similar surfaces. So I've selected these two fillets here. When I right-clicked and said select similar, it selected the surfaces over here as well. And I can remove those just through like an extend. And so I can select an entire blend chain and remove them. And so it's a really quick way to remove a lot of fillets from your model, as well as you select a blend chain and you want to select any other blend chains that are equivalent to that. That's going to select the opposite side as well and remove them. Say that we want to remove like these little holes that we don't really care about. We can select the cavity, select similar. It'll select all of these little holes and we can remove them. If you select a surface and say just from your mouse, you maybe had just missed by a little bit. If you hit the tab button, it'll cycle through selections. So by selecting a single surface, I can then find that internal surface. So I'm going to select this hole, select similar. It's going to select the other hole over there. Insert those into my pick widget, remove them. And similar story with these holes. So again, through the right-click context menu. So now, as I was saying, let's imagine that the challenge I've got is I'm trying to mesh this little standoff here. So one of the things I might want to do is I just want to extract out that single volume. So I'm going to web cut my geometry until I've got that volume kind of isolated. So I'm going to sweep a surface here. And sweep this surface perpendicular. Oops, that's not what it's actually not, well, not what I meant to do. I meant to chop plane from curve. So I'm going to cut this volume. I oftentimes like to do this preview to see what my cuts are going to be doing. We're going to draw this volume by itself, and then I should be able to sweep curves. So I'm going to cut this volume with these curves swept in the -1, 0 direction. All right, so we just need to do a couple more cuts here. So let's sweep surface, perpendicular first. This may actually do what we wanted. Good. So one of the things I wanted to do here is this fillet. If we had chopped this fillet instead by a plane surface, so if we had used this plane, do you see how that would have led to kind of a tangency on my cut? That would essentially be really difficult to hex mesh. If you were to refine your hex mesh, you get closer and closer to a tangency, which would result in worse and worse hex element qualities. That's why when I saw that fillet, I chose to do a web cut that would instead result in me getting kind of this perpendicularity at that. So I went from a tangency to something that's perpendicular. And that's really crucial for if you want to try to keep those kinds of features in your model. Now, for simplicity here, I'm going to remove all of the other volumes. So I'm going to delete all volumes except for volume 4. So I'm just going to type it in my command line here, delete volume all except volume 4. And that's using the extended Boolean functionality of the command line. And then I'm going to compress. And I've just done that just so that we can just show how we're going to mesh this one volume and use compositing to help us out here. So if we just explore this volume a little bit, some of the things we'll notice are I've got these shoulder fillets that these curves, if I kind of like look at them, they don't quite line in a plane. And some of these are like a straight line, but this is like an arc curve that kind of comes out of the plane. And this curve takes like another angle. So you can kind of see, I can't really do a cut. Oh, and one more surface I meant to remove here real quick is this little surface. There we go. So I can't just chop off maybe. It's maybe a little bit confusing how we would do that. So what I'm going to do is I'm going to start by I've kind of mentally already have segmented this volume into different regions. I can kind of see how, again, I can get myself perpendicularities by, say, chopping this volume with this curve, taking the normal at this vertex, which is going to just, oops. But yeah, that's right. So even if we were to do that, you can see that I don't even have planarities here. And so oftentimes a similar functionality to like the plane from curve is to actually do this sweep surface. So I'm going to take this volume, I'm going to sweep this surface perpendicular to itself. And then that's going to get me that nice little cut across that surface here. So that's the cut I'm going to do. So hopefully that's kind of clear why I've done that. But that separates this volume from everything else. Similarly, I can kind of see that I can get a perpendicular cut if I chop this volume here. So what I'm going to do is I'm going to choose a plane vertex. I'm going to cut this volume. The 3 vertices I'm going to use are going to be these 3. Now, what you'll notice is if we look at what this cut is going to do, we can tell I'm going to get some thin kind of slivery surfaces that maybe would be traditionally really difficult to mesh. But we're going to utilize compositing to remove those away. So if we just draw this volume, again, we see that there are those slivers. What I can do is I can come in, I can composite these together into a single surface again, which will get rid of them. So we know that we can do that. We're going to hold off on that for now because we're going to do some more cutting of this volume. But that's going to be our strategies. We know we can come back through and composite. What I'm going to do is I'm going to try to cut this so that I'm going to kind of try to cut in like an H here to chop off these shoulder fillet regions. And then I'm going to be kind of like left with a square in the middle. So again, I'm going to use chopping by plane vertex. So I'm going to choose these vertices to make this cut. And then I'm going to use these vertices to make that cut as well. And I'm going to cut all of them with vertices that come from these volumes to make this cut. So again, we haven't really bothered with worrying about this topology that we've created.
So Greg, why at this point are you making all these cuts? Because you could strictly just sweep from one to the other now.
I could. So there are some abilities to do that, but the problem is going to be that when I reach the other side of this volume and I'm going to hit these shoulder fillets, that's going to end up being a tough topology for Qubit to mesh. So I'm kind of planning ahead where I'm going to try to build each individual volume with merged surfaces. And so we're going to kind of cut this down to its maximum cutting, partially so I can also show the compositing in work. But it's really that this volume is the challenge. These shoulder fillets are the challenge of this model, where traditionally I might just, because they're so challenging, I would remove the surfaces and make them sharp corners and get rid of that issue because of that. That's a good question. But I typically find that when I have problems that are like this, that I find that these work really well if I just kind of chop them up as much as I can. So I'm going to draw vol all except vol 2 and 3. But thanks for the question. That's a really good question, and it's really insightful. So now what I'm going to do is I can use that same select cavity or select continuous to select all of those little sliver curves in kind of this feature and composite them together. And they're only, because these are separate volumes, they're not stretching over to the neighbors. And so I'm just going to select all of these here. here, and here. I think I've got them all. One way is you can kind of check to see if you've got them all is if as you go across, especially if you've got just those slivers, they'll show up as a select continuous. And so if you can't select continuous, or if as you do a selection, if you only get one surface, then you're pretty confident you've only got one. So then one of the things that's kind of nice is this kind of geometry. We just draw this. This is tailor-made for this polyhedron scheme, which will put a pretty good quality layout of hexes on that volume. So what I've kind of done by doing that decomposition is I've left myself with some volumes that I know I can mesh with polyhedron. And then I've got some nice or some other surfaces that maybe are going to be like nice structured. So I've kind of built up what that sweep could have looked like, but I really do like to cut them up like this. If we delete the mesh, we can kind of look at the neighbors. If we were to do a quick imprint all here, we'll notice that this neighboring volume is going to have that topology coming from its neighbors. That is, again, needing to be able to sweep through. So I'm going to even have these cuts go through this volume. I could have done cutting all the volumes all at the exact same time. I wanted to show why we might have done that. That again, when we want these conforming meshes, we're going to have topology shared across these boundaries. And it's this topology that then has to work its way over to the shoulder fillet. So let me quick here, I'm going to draw this volume and then with this volume so I can kind of quickly get what those cuts are. I can cut my volume from plane surfaces. In fact, I'm now going to do all. So I'm going to cut with this plane. Oh, actually, no, I don't want to do that because that's right. All I really need to make sure is that I'm going to capture this topology in here. So I actually just want to do plane vertices still. Cut this volume. I'm going to say grab some of those vertices that were coming through from that previous layer. Oops, and then on to, and then kind of like mapping it onto this surface at the top here. And so you can see again, I'm going to kind of be compositing that shoulder fillet away as well with that same kind of technique. And then select these volumes, cut with the vertex. Actually, let's see, I don't think I want to actually do, say, these three vertices. And then we're going to want to cut on these vertices. So again, I'm trying to keep that topology from the neighboring section so that I won't have to go back and recut my previous volume. But again, so what I'm gonna have to do now is I'm gonna rely on compositing to mesh these individual sections. A couple other things I'm gonna do. I'm gonna pull those kind of running short in time, so I may just kind of give an idea for what I'm gonna do next here. I'm gonna cut my volume in half so that I don't have like this large volume around this circle. So I'm gonna do a plane from a curve. I'm gonna select all of these volumes. And then select this curve at its midpoint. We won't do it at its midpoint, maybe we'll do it on this curve at its midpoint. And then I'm going to cut these volumes again along these curve midpoints. So what I've kind of done is I've now got some kind of blocky sections that I can see how I can build, or how Cubit's going to be able to build this. I can even do like a polyhedron mesh on these volumes. So I've kind of broken it down into these kind of elementary volumes that I'm going to be able to mesh. But just to then show more of this compositing in play here. So again, if I'm just going to composite surfaces, I'm going to select continuous surfaces. I can probably select similar. There's probably duplicates on the other side. And just come through and composite these all away. So that's kind of the strategy that I've done here. I think we're just about out of time, Matt, so I may leave it here, but this is the strategy of compositing away so they don't have to worry about trying to mesh this complex topology in my resulting mesh. So what I'm left with is I'm going to be left with volumes. Oops, that's a surface. I'm going to be left with volumes that are then meshable with one of these elementary schemes like polyhedron. And so that's going to be able to be, that's how this shoulder fillet is going to be able to be meshed then and still conform with its neighbors. So if I draw it, say with these neighboring volumes here, just to show that. So because I don't have to worry about this extra topology, if I do this imprint and merge to be able to get my conforming meshes, oops, we typically start with, let's mesh the polyhedron volume first, and then mesh the neighbors. So that's how we're going to end up building this model, is through that decomposition and compositing of surfaces. And so you can see there's a lot of surfaces here that we're going to go ahead and composite away. And that's typically what my strategy for meshing these kinds of volumes, where I really care about getting highly accurate results for plasticity and stresses in a high quality analysis. And I like to build these meshes kind of from the ground up like that. So Matt, if there are questions, we can go ahead and field them now. I'm happy to continue finishing this if we still have time.
I mean, I think we're all enamored and want to just see the mesh.
All right.
Maybe you could continue meshing, and there are some questions coming in.
Great.
So the extent that you can talk and mesh at the same time, this will be your test.
Perfect.
So one question is, as you were determining what scheme to add to these, there's like an automatically detect function for the meshing schemes. Would that detect polyhedron? Yeah, the automatically calculate. Is that reliably going to predict the right one, or?
So I have found that the automatically calculate almost never predicts polyhedron scheme. So typically what I'll do is, again, kind of my strategy is before, so I should actually unmerge now. Before I ever do the imprint merge and mesh, is I will typically just try to select all and mesh all the volumes separately and see what volumes don't mesh, right? And if there are volumes that don't mesh, that could either be that they have topology that's still like a challenge, like I haven't composited these surfaces yet, or that they are a polyhedron scheme. And so one of the things I kind of like to do, right, is it'll give you an error for what volumes didn't mesh. And so you can kind of just copy this and say, draw a volume, and it'll draw you those volumes. And you can kind of then quickly see, I could make out, oh, that's a polyhedron scheme. These I need a composite, but then they're going to be a polyhedron. These guys are polyhedron. And that's kind of my approach. So if I had done this, I'd say, okay, I know that I want to composite these surfaces. And then I want to apply a polyhedron scheme to these volumes. Again, I'm getting that warning because I haven't yet done my imprint and merge. But essentially, if you can't build a mesh before everything's imprinted and merged, you won't be able to mesh it once they're imprinted and merged. Imprinting and merging makes it makes the problem more challenging. So I always like to try to mesh with prior to imprinting and merging, see what kinds of volumes might have to have a polyhedron scheme, and then I move forward. And then I'll do like imprint and merge and see how things update. Yeah, that's a good question. Yep.
Good. No, and that's really helpful just to see how you approach this. Those bag of tricks are really valuable. Yeah, maybe we'll let you finish this up. Here's another question that came in. You can choose to answer this now or after you're done. How do you mesh volumes that have very sharp angles and are cylindrical at the same time?
I'm not sure if I understand what the geometry for that looks like.
Yeah, maybe I could finish this up, and then Ibrahim, if you can clarify it all, you can take a stab at that.
Yeah, maybe if you've got if you can find a picture on Google Images of something that's similar or something, and if you find a link, you can drop it in the chat, or if you're able to share even a screen, if you're able to share like an example, we could maybe even talk about it. But yeah, without seeing it, I'm not sure I quite understand what it is, unfortunately.
So where you are at right now when you're troubleshooting this, Greg?
So right now, what I'm doing is I'm propagating my cuts through my volume. So I'm just propagating them up. These aren't strictly needed, but since I've already kind of gone in, I mean, I've kind of decided that this is like the one volume I care about, or the one region I care about. And so I am okay spending time doing extensive web cutting on this singular area that matters to me. And I want to make sure it's robust. And so what I'm doing now is I'm just coming through and propagating my cuts through my model.
Yeah, because it looked like you already meshed this successfully, right?
I meshed it with without having it imprinted and merged. And so it was that would be a non-conforming hex mesh. So the regions weren't connected yet.
But you could have just imprinted and merged directly.
I could have, but that may have resulted in some challenging topology that I'd need to come through and handle. And so I chose to, instead of relying on the imprints and resulting in maybe a challenging interval solving problem, that I'm going to come through and propagate my web cuts through. So if it's crystal clear to me how the volume gets meshed, it'll be crystal clear to Qubit how it's supposed to be meshed, is what I'm banking on here. So I think that should be about it. So one of the things I kind of like to do is, if I've done all of this extensive web cutting, I should probably just double check that I don't have any other slivers. I should be able to now just do a merge all. I can draw a surface all with is merged. So I can see if there's, so I can see one of the things I can see is that there's between, let's see, where was that? Yeah, so I've got some surfaces that didn't get merged in between. So that might be where I would go ahead and now just do well, I guess I want to composite this surface, don't I? So let's composite and similar, composite those away. with is merged. It looks like I've got every surface. We're just about missing a couple. So I may do at this point, do my imprints because I'm pretty far along. So imprint all. Let's try our merge all. And what I probably need to do, so I can again do I'm going to reset vol all. I'm going to mesh vol all to see what the default schemes get assigned and what ones struggle. So again, I've got these 6 volumes that didn't mesh. I'm going to set them to polyhedron. And then I typically like to mesh those volumes first. But actually what I'm going to do is I'm actually going to start by meshing from one side and then through and up. So I should be able to mesh these volumes all in one go. If they can't, probably need to set this to a polyhedron scheme. I think it's probably a sweep. So let's set our polyhedron scheme. Yep, they were sweeps. So we'll mesh those. And then these are just maps. So we should be able to mesh those volumes. So those guys are done, out of the way. And then we can see about trying to mesh these middle volumes. I'm going to draw these by themselves. Looks like it's going to all mesh. These guys probably need to be meshed first. So let's go back to our, we'll mesh these volumes. Mesh these middle volumes. Okay, so this is where we've got, let's take a look at their topology here.
It's really interesting how the order matters here, isn't it?
It is, yep. Typically, I like to go from most constrained volumes to least constrained. So these are clearly a constrained volume. Let's take a look at these two together.
So why are you turning on the vertices here?
I like to see vertices. It helps me find if there's maybe a small sliver curve somewhere, or like a vertex that I hadn't expected. So if this curve down here might have been like, say, 2 curves, then I would see like a black dot here, and that might be helpful for me to understand what's going on. Okay, so we mesh those together at the same time. Let's see if we can now mesh these volumes. Volumes around. Let's draw these volumes here. See if we can get them all in one go. We did. Should be able to now mesh these volumes on the very edge. Okay, so we just missed on these little shoulder fillets. So we kind of are making like mental notes here that I've got to be able to mesh these guys probably first, along with those other polyhedrons. So we're going to kind of extract out what seem to be the challenge volumes. Mesh these, mesh the shoulders. All right. Yeah, so we've got interval matching is failing here. That's what we're dealing with. And that's again, just like from composite or from imprinting and merging becomes a challenge here. So let's try. Meshing out. See if we can mesh. Okay, so let's try from here now. Yeah, so we're running into, let's see. This is had this working earlier today, so I'll have to maybe figure out what's going on here. Looks like I should be able to sweep this volume. So maybe it's just my sweep directions need to be modified.
You know, thanks for wrestling this, Greg. This is like where most of the time goes with hex meshing, so it's really helpful to see you
Yeah.
use different approaches.
Yeah. And again, my typical approach is that you kind of have to like play around with some of the meshing to get a feel for what like the most constrained regions or volumes are. Like the polyhedron scheme has some requirements on it as far as you know, what the surface schemes end up needing to be. And so those end up oftentimes being kind of the restricting. So it's kind of a game of trying to figure out how to build that mesh in that manner. So let's try something else here. Let's try meshing, set my sweep schemes here. Might have accidentally changed those to away from polyhedron. Whoop. Well, I managed to crash Qubit, unfortunately. So sorry about that. That little demo didn't quite work, but that's if I work that problem a little bit more, that problem becomes meshable through compositing. So I'm sorry that I'm using one of our development builds of Qubit. So I've got a couple instabilities. Because this volume looks like it failed to mesh. It's probably just I need to switch my surface or source and target surfaces to the other direction, if I had to guess. And I'm going to go ahead and even do that compositing that we talked about. Anyways, but I hope that this kind of shows compositing and how it can be used on some of these challenging sorts of models as kind of a tool to redefine the topology that's going to be tracked by your mesher. So I guess, are there any other questions, Matt?
No, that's super helpful, Greg. Yeah, there's a couple of the questions that have come in, but I've asked them to just redirect to the form because they're
Okay.
about slightly different topics, and it's been really useful what you've showed so
Cool. Great.
far. So yeah, so I guess in conclusion, again, thanks for spending some time with us today. Hopefully that's helpful for you to see different techniques to approach composite meshing in Qubit. And we welcome engagement with you with questions on our forum. And again, if you're trying to decide if Qubit's the right tool for you, reach out and we'd love to have some technical chats to accelerate that decision. So thanks again, everyone, for your time.